circle of logs. We're gonna do the circle logs. Alright, so let's go ahead and get started, jokes aside. Alright, so I put these two problems up because I think these are probably two of the ones that you'll find difficult on the homework. Next class we're going to do things like properties of logs, like for example adding, subtracting, multiplying logs, and I have like a really good examples to put up that'll help you understand why those properties exist. So I'll have that for you guys next class. Also put up a video for that one. Alright, so if we look at A, we have log base 2 of 2 to the power of n, and if I check if n equals 1, 2, 3, etc., how could we simplify this? Well, let's go ahead and try if it was log base 2 to the power of, log base 2 of 2, and it's to the power of 1. Well, that's kind of unnecessary to have that 1 there, so we don't need that. It would be log base 2 of 2, right? So how could I simplify that? 2 to what power? And this is what I typically do, is I just make it equal x, so I can simplify it. So log base 2 of what? So 2 to what power equals x? And this goes back to our circle of logs thing. We have 2 to what power is equal to 2. So it's going to be 2 to the power of x is equal to 2. Well, looks like this has to be 1. Okay, so let's try another one. Let's try log base 2 of 2 to the power of 2. Alright, so now we've already tried 1, and now we're trying 2. Alright, so let's see what this looks like. Well, to simplify this, I typically like to set it equal to x, so it gives me an idea. 2 to what power gives me 2 to the second power. So let's see. What is it saying? Well, let's reduce this down to 4. Okay, so this is really log base 2 of 4 is equal to x. So that gives me 2 to what power is equal to 4. So that's 2 to what power is equal to 4. Well, that means x has to be 2. Okay. What kind of pattern am I seeing here? For the first one, I put 1 as the power, and I ended up getting 1 right here. Second one, I got a 2, and I got a 2 over here. Let's try one more time. So let's see if that same pattern follows. Log base 2 of 2 to the third power. I'm going to switch that to log base 2 of 8. And we want to figure out what that simplifies to. So let's take the circle of logs, and now we have 2 to the power of x is equal to 8. Wait a minute. It looks like x has to be 3. And there it is. Right? So for all of these, if I'm to simplify this, what happens when I plug in these n's right here? Well, this is actually one of the properties that we're going to learn next class, but this is kind of like the reason why, is that this cancels out the 2 and you're left with n. So if we plugged in n equals 1, like 2 to the first power, well, it would be log base 2 of 2 to the first, and that just became 1, which we showed right here. If we plugged in 2, we got that one right there. If we plugged in 3, we got 3 right here. So it ends up just being that, to simplify this, whatever we put in for n, we get n. And these are one of the properties that we'll talk about next class, but one of the questions in this class is kind of like a precursor. So it essentially like makes you think about it and just kind of see the proof of it. Alright, so let's do the next one. And again, we have another circle of logs. Alright, so to simplify this, I normally set it equal to x to kind of give myself an idea of what it's going to look like. So 0.01 to what power is equal to 1,000. So 0.01 to what power is equal to 1,000. Okay, So a lot of times I don't like these decimal things because it's harder for me to see. So I'm going to convert this into a fraction. Right, so that's 1 over 100, right, because it's 1/100th. 1 over 100 to the power of x is equal 1,000. Okay. So let's see. Now it's going to get a little more complicated, and I think I actually made a pretty bad example, so I'm going to add one more 0 here. There we go. Because I don't want you guys to have to pull out a calculator yet. So I'm going to put in one more 0 here, and you will see why. So the first thing I'm going to do is, what if I made this x a negative? So for example, 1 over 100 to the power of -1. That equals 100. Okay, so we're almost there. What about 1 over 100 to the power of -2? Okay, well that puts me at 100 times 100, which is equal to 10,000. Okay, so now I have my correct answer. 10,000 is what I wanted, right? So what did I choose for x? Well, I chose x equals -2. So to simplify that one, this log right here, log 0.01 to the 10,000, or log 0.01 of 10,000, that's x equals -2. Now, just to make sure you guys kind of saw why I had to add the 0, because I added this 0 right here, it made it possible to have a nice round number. Okay, this is 0. Otherwise, it wouldn't have worked out. For example, notice that it goes from 100 to 10,000. It never touches 1,000. So, you know, 100 squared gives me 10,000. 100 to the first power is 100. It never touches 1,000. So that's why I had to add in that extra 0. Alright, so next class we're going to just, you know, go over a lot of property things. I have a really good, like, lined up, like, we'll fold our papers and essentially, like, kind of like prove each one and just come up with the idea of, you know, why these properties exist. So next class, be ready for that. Additionally, I'm going to say this. We have about a week left, so as a heads up to you guys, there's a possibility that I'm going to do like a 2 or 3 question quiz next class, just like a homework quiz, just so you guys, like, I have a good idea of where you guys are at. So expect something on logs, maybe one on inverse, and one from the section before that, which is exponential functions. So maybe expect 4 problems, because I probably want to see you do a circle of logs this way and a circle of logs going the other way. Okay, alright, peace out.